Okay. Session එක close වුණා. ආයෙත් වෙනම් බලමු. But from the beginning. So they have given the weight, and by using W equals mg, I found the mass. Okay. Then I take this mass here. So they have given the momentum as 6 kg ms minus 1. So by using P equals mv, I put 6 here. Half is the mass, and the velocity is 12 by the simplification. And again, acceleration we don't know. Again, I put the data: starting velocity 10, ending velocity 4, time taken is 4. So the difference minus 8 divided by 4 minus 2 ms minus 2, that is the deceleration. Okay. Then I apply the values to F equals ma. F equals ma, mass half kilogram, acceleration minus 2. When you simplify, you answer minus 1 Newton. That is opposite to the motion. If it is the deceleration, the force is opposite to the motion. That's why I have written in a sentence. But if you come to this place, you will get the marks. But this is for additional explanation. The force acted opposite to the motion is 1 Newton, right? So that's how you do it. If you want, you can take a screenshot. Right. So we'll continue to the next lesson. Right. So this is the So hopefully I'll be able to upload the recorded video at the end of the day. We'll try. So you can take the screenshot. Okay. So then we'll load the lesson number 5. Lesson number 5 is a small lesson. It is friction. So I'll try my best to upload the video for the lesson number 3. So still I couldn't make it. But don't worry, this is again a physics lesson. So again, this has a connection with the unit number 4. In the unit number 4, we talk about something called friction, right? And in that one, we said friction is an opposite force, and it will be discussed in detail in oncoming lesson. So this is the oncoming lesson. This is the lesson number 5, which explains about the friction. We'll see. I'll try to share the tute for the people who don't have it. Till then, don't send messages, right? Okay, it is shared. Yeah, there's a connection problem from the morning. Now it was okay later. Now I don't see any kind of a connection problem, right? So your file is uploaded, unit number 5. Right. Like that. See, nature of friction. So as I told you earlier, in that day, friction is a force opposing the motion. Friction is a force opposing the motion. That day we discussed when we try to push something, when we apply a small force, we can't push it. The reason, my force is cancelled off by the automatically generated frictional force, right? So the frictional force will act on moving objects, or if an object has a tendency to move. Move වෙනකොට හරි move වෙන්න පොඩි පෙළඹවීමක් තියෙනකොට හරි තමයි friction එක එන්නේ. If it is not moving, and if there are no forces acting on it, then there is no friction. Forces activate නැත්නම් දැන් ඔයා මේස් තල්ලු කරන්න උත්සාහ කරන්නේ නැත්නම් friction එකක් නැහැ. හරිද? තල්ලු කරන්න හදද්දි තමයි friction එක එන්නේ. දැන් ඔය මිනුලට තමයි මම හිතන්නේ මොන හරි මේ bandwidth එකේ problem එකක් තියෙනවා. මොකද අනිත් අයගෙන් complaints නැහැ හොඳේ. ඔයාගේ connection එක පොඩ්ඩක් බලන්න. හරි. Right. So it is not very clear. So the friction is not a very big thing. So there is not particular mentioning about person who discovered it, right? Anyway, maybe Newton has something to do with it, but we have to check who has discovered it. But anyway, we'll go with the truth. We had an understanding about the friction in the previous lesson. It was explained that the friction is an opposite force for the motion. We know that. Let's look at an example. Think of an instance where a boy is trying to push a table. He's trying to push a table. At the beginning, he is applying a very small force. With a small force, the table cannot be moved. The reason is opposite force applied by the flow has cancelled out the force applied by the boy. Both forces are equal in magnitude and opposite in direction. So they cancelled out. This opposite force is called friction. අපිට කියනවා self adjusting force එකක්. It is automatically generated and it is automatically changing according to your force applied. Self adjusting force එකක්. Even when he increased the force applied, the table does not move. That means the friction also can increase automatically up to a certain maximum level. When boy's force exceeded the maximum friction, the table starts to move. Here, the frictional force could not balance the boy's force. So the table will move only when the frictional force cannot balance the external force. If frictional force is smaller and the external force is larger, then the object moves. Until then, it will stay at rest. ඉතින් අපි එදා ඇඳ වගේ තව diagram එකක් මෙතන ඇඳලා දාන්න පුළුවන්. හරි. එදා එක මතක් වෙන්නත් එක්ක. Okay. We'll draw a small diagram. I am applying a small force. Friction becomes smaller, equal to that. Right. So assume the maximum friction is say 50 newtons. I am applying 50 newtons, not moving. Right. I'm sorry. I am applying. We'll take a moving friction here. I'm applying 20 newtons, maximum friction 15, and it is moving now. So this is a diagram you can draw. You can draw it. So any problem with the connection, I can't solve, right? So I have taken one of the best connection from the dialog and I have paid everything. So even if it is not supporting, then there's a problem I cannot solve, right? So you have to bear with me. So this is Sri Lanka, right? Okay. Diagrams ටික ඇඳලා ඉවරයි ඇති. Then there is a definition for the friction. Actually, it is kind of a big definition. We'll try to understand it. Ready? The forces that act between the surfaces of two objects in contact with each other to oppose the relative motion when the objects are moving relative to each other, or to oppose the tendency to move when the objects have a tendency to move relative to each other are called frictional forces. හරි. ඉස්සෙල්ලා ඔක ලියන්න, then I'll explain. මේක ලියා ගන්නකො මෙතන මේ dotted lines වල. මෙන්න මේ blue color box එකේ තියෙන විස්තර. කලින් session එකේ recording එක මේක උඩට ඇවිල්ලා තිබ්බා. අර ලියාගෙන බැලුණා නම් තත්ත්ව වෙලාවක් දෙන්න. මේගොල්ලෝගේ textbook එකේ තියෙනවා බලන්න ලියන්න පුළුවන්. So that is for the definition for the friction. For the meaning is something like this. Now, if there is an object which is kept on the table, right? I am applying a force and moving it. So when I am moving it, there will be a frictional force created opposite to the motion. Created opposite to the motion. Now, if it is moving in this direction, friction will be onto the other direction, right? And I am applying a force and it has a tendency to move. Still, it's not moving. Then the movement, it has a tendency to move. Then again, friction will be to the opposite direction. There's a tendency to move, but still not moving. Then friction is there. Or else, when it is moving, again the friction will be there. Tendency එකක් හරි move වෙනකොට හරි තමයි friction again. Okay, let's go back to the tube. Right. Not only in solids, friction can be seen in liquids and gases. So there are kinds of friction, but we don't use the word actually, but it is like friction. Now, when we when we are traveling in a vehicle, and if it is safe, when we put our hand out, we can see that our hand is pushed backward by the wind hitting on the hand. That is the air resistance. So it is kind of a friction. So same thing will be happening when we are going in a boat. When we put our hand into water, the hand will be dragged back because of the force created by the water. Okay. Now, when we are talking in detail about the friction, there are basically three types of friction. They are called static, limiting, and dynamic. Static friction, limiting friction, and the dynamic friction. The frictional force is of three types depending on the way that they act on bodies. Static friction, limiting friction, and the dynamic friction. මෙන්න තියෙනවා. එතකොට අපි මේ boxes තුනේ ඉස්සෙල්ලාම ඉස්සරහින් ලියා ගන්න ඕන. මෙතන ඉස්සරහා පොඩි ඉඩක් තියෙන්නේ. මට ඒක එතන පොඩ්ඩක් තියන්න බැරි වෙලා තියෙන්නේ. මෙන්න මේ හරියෙන් ලියන්න ඕන static friction, limiting friction, dynamic friction. Static, friction, limiting friction, dynamic friction. මේක ඉස්සරහා තමයි අර විස්තරය ලියන්නේ. හරිද? මේ විදිහට ඉස්සරහින් විස්තරය ලියන්න මේ words තුන දාලා. මම එතන book එක load කරන්න. හරි? අපි කියවලත් බලමු ඉස්සෙල්ලා. The frictional force that act when there is no relative motion, even though a force is applied on the body. So we are applying a force towards the body and it is not moving. So in that case, my force is cancelled off by the static frictional force. So under the static frictional force, there will be no movement of the object. එයාට motion එකක් නැහැ. නැවතිලා තියෙන friction එක තමයි static friction. The second one, the frictional force that act on a body as it just begin to move. Motion එක start වෙන තප්පරේ fraction of a second. ඉතා සුළු වෙලාවක තියෙන frictional force එක තමයි මේ limiting frictional force. It acts only at the point of start in the motion. So it is the maximum frictional force between the two surfaces. එයා තමයි ලොකුම frictional force එක. Third one, the dynamic frictional force. When the object is moving, there will be a frictional force between the two surfaces. That is called the dynamic friction. So under the dynamic friction, the object will move. So you can write static friction, limiting friction, and the dynamic friction, and complete the three boxes using the data in the screen. Are you okay? So we'll continue. Activity. Do this activity by pulling a block of wood by using a Newton balance. Now here you have to draw this diagram. I'll take it onto the screen. Now this one. Now there's a block of wood kept on the table, and a Newton balance is connected to it. And we are applying a force with the help of the Newton balance onto the block of wood. And we measure the minimum force needed to start the motion. Right? We can record the minimum force to start the motion. So first of all, we have to draw the diagram. Hurry up and draw in this box. Okay. Okay, the diagram is finished now. We'll go to the note. Increase the force applied and observe the motion of the block of wood. Even when the force is applied, the block of wood didn't move because our force is balanced by the frictional force. It started to move when the frictional force could not balance our force. It starts to move, the maximum frictional force exerted by the surface of the table to oppose the motion is equal to the force necessary to just start the motion. So they are talking about the limiting frictional force. At the starting moment, as the starting of the motion, maximum friction is equal to the force that we applied in order to move it. Whenever the force applied on the body is smaller than the maximum frictional force, the surface of the table exerts a frictional force on the body that is equal to the opposite to the applied force. So when it is lesser than that, so always the table will not, or the surface will not allow the object to move. It apply a force equal to my force to stop the, or the cancel the motion. This frictional force exerted on the body before the motion starts is called the static friction. So මේ විදියට motion එක start වෙන්න කලින් තියෙන force එකට අපි කියනවා static friction. When the static friction is at work, object will not move. Under the static friction, object will be at rest. So I'm going to draw several diagrams to explain it. Just like in the lesson number 4. I'm applying 5 newtons of force. Friction again becomes 5. Not moving. 10 newtons. 10 newtons. Not moving. 15 newtons, 15 newtons again, not. So this frictional force is named as static frictional force. So you can draw these three diagrams in that box. Okay. Hari. So then we'll go to the next one. When the external force is increased, the frictional force also increased. But this increment is up to a certain value. This maximum frictional value is called limiting frictional force. Now, when it comes to the limiting frictional force, the object will start to move. Motion will be started. Motion will be started because of the limiting frictional force. And for the limiting frictional force, we can draw only one diagram. So assume the maximum frictional force that can exist between the two surfaces is 17 newtons or the 20 newtons. Maximum friction 20 kila. It is a limiting condition. Limiting situation a special incident එකක් එතනදී අපි 20 newtons දැම්මහම okay the object will start to move. එතකොට ඊළඟ box එකට එක diagram එකයි මේ මම අඳින එක්කෙනා විතරයි. මෙයා විතරයි එන්නේ. එතකොට මෙතන ලියන්න පුළුවන් start to move. Moving කියලා දාන්න බෑ. Start to move කියන්නේ එක පොඩි වෙලාවකට විතරයි. ඒක ස්පෙෂල් කේස් දැන් ඔයගොල්ලෝ අහයි දැන් මෙතන 15 move නැත්නම් මෙතන 20 move වෙන්නේ කොහොමද මේක limiting situation. It's a special kind of a situation. Therefore at the limiting situation when our force is matched by the limiting frictional force it starts to move. Motion එක start කරලා දෙන්න. හරි motion එක start කරලා දෙන්න. ඒකයි කියන්නේ. මේ එක diagram එකයි ඊළඟ box එකට එන්න හරි. Okay. So the last situation, the dynamic. So once the motion of the object started, when it is started to move, as soon as that this frictional value, the limiting value will be reduced slightly. Make a chuttak aduna apitamo newtons 19කට drop වෙනවා. ඊට පස්සේ දිගටම ඔය 19 කියන එක තමයි තියෙන්නේ.